Hello and welcome back to my channel. Today is the sixth session of the series ConQuiz. Hope you have watched the earlier 5 ConQuiz series episodes. And as you know that in the earlier 2 sessions, we have started concept booster on chemical kinetics. In the fourth one, we have started with a quick review, short answer type questions and true and false type of questions. And in the fifth session, we have explored some of the important equations of chemical kinetics. We have deduced those equations and demonstrated that how those equations can be applied for different kinds of problems. And today is the sixth session and you will get the part 3 of chemical kinetics, and today we will be understanding the diagrams or understanding through diagrams. And as it goes like that, a picture says thousands of words. So diagrams or profile or graphs, whatever you say, they play a crucial role in understanding science in general and particularly chemical kinetics. So today we'll be drawing some graphs. Okay, so two things I'd like to point out, that if you have not watched or listened to the ConQuiz 5, you please stop here, go back to ConQuiz 5 episode, because in that session we have discussed the important equations and which are actually the basis of any diagram. So for today's session as well, they are very important. And the second point is that today, as you see, that the talking speaker is not visible on the screen because of some technical problem, because I want to draw some of the diagrams on the screen to give you a feelings of the real class. So that's why I am not visible on the screen. So let us start. But as I mentioned always, the purpose of this series is, of course, it's a concept booster series, but it would also help you to prepare for different competitive exams, including the basic chemistry honors degree exam, plus IIT JAM, NET, GATE, SET, etc. So let us start the session 6. Draw the plots of. So some of the informations or data would be given in the question, and accordingly you have to give a profile of some y versus x. So let us see one by one. The first one, concentration versus time of a first order and a second order reaction starting with the same initial concentration of reactant 1 molar and same rate constant K. So what we need is the integrated rate expression for concentration in terms of T for first order and second order, and that we actually know. This is the first order expression is A0 e to the power minus KT, an exponential decay equation, and the second one is this one. This particular and the first glance actually you will get this equation, but here A is expressed in terms of T. So you need the second one, A on your left and T is on your right. So let us try to draw the diagram. Obviously the first one is straightforward because it's an exponential decay, so it would be like this. So if it is the y-axis is concentration of A or AT and x-axis is time, then the initial is A0, because when t equal to 0, then e to the power 0 is 1, so A is A0. So it starts from A0, and when t is infinity, then e to the power minus infinity is 0. So after infinite time it would go to 0 actually. So better you just draw an exponential decay, but don't touch the x-axis. So you can put some you can put some dotted line here up to 0. Okay. So this is the first one. So this is the first order, and the second order, you see T is in the denominator, right? So with increasing time the denominator value increases, so the overall right hand side decreases, but the rate of decrease is not as fast as that of the first order. So it is not an exponential, but it's a different kind of, but it would be a decrease. So let us draw like this. So this is the second order plot. Okay. So hope you have understood that what we are going to do in this particular session. So let us go for the next slide. Rate versus time for a first order. Rate versus time. What you usually see that rate in terms of concentration Ka. So usually the questions comes like that, rate versus A or log A, this kind of. But here rate versus time. Time is not explicitly there, R equal to Ka in that expression. So you have to bring into the factor time. So how you can do that? You have to differentiate rate with respect to time. So dr dt. So you need dr dt. Okay. So that means K is a constant. So dA dt is coming here. But as you see, the dA dt is minus R. So dA dt is replaced by minus R. So what we get, dr dt is minus K by K into R. So you bring R from right to left to the denominator. So you get dr bar R by R equal to minus K. So now your task is to just integrate. So dr by R over the limit R 0 to R is minus K dt, 0 to 2 t. So the result is ln R by R0 is minus KT, and for final result is R is R0 into e to the power minus KT. So what is the desired equation? R as a function of time, right? And again we see that's an exponential decay equation. So it is simply time is x-axis and rate is y-axis, and it starts from some R0 and it is an exponential decay. Of course, the rate of decay would depend on the rate constant K. Okay. So this is how we usually handle this kind of plot, rate versus time. Okay. So let us go for the next slide. Product concentration versus time plot for a zero order reaction. So A to P, the reaction, and rate can be expressed as either minus dA dt, as you know, or dP dt, and that is equal to Ka to the power 0 because it's a zero order reaction. So R is basically K and dP dt is K. So dP is K dt. If you integrate putting the proper limit, you will get Pt minus P0 equal to Kt minus 0. That means Pt is P0 plus Kt. So the question demands a plot of P, that means Pt versus time. So Pt or P versus time, and of course it's a straight line with slope K and intercept P0. So it is like this, and the slope is, you can usually denote like, so this is slope and that is equal to K. Okay, and this is the intercept which is P0. Well, if you assume that there is no product to start with, that is P at time t equal to 0, P itself is 0, then it's going to be no intercept would be there, so it will be passing to the origin straight line, and again the slope is of course P. Okay, so that's all about the question number C. Now question D, product versus time, again time, for a first order reaction, A arrow. So as you know that A is A0 into e to the minus KT, but in this expression A is AT actually, that means the reactant concentration, but what we want is the product concentration. So how we can bring into that term P? So as you know that AT at any time t, AT is nothing but the initial concentration minus the amount of product, that means product concentration that has already been produced in that time. So A0 minus P is actually AT, and that is equal to A0 into e to the minus KT. So P is A0 into 1 minus KT. So P, if you take on the right, and this thing you can bring to left, and you will get this equation. So P is A0 into 1 minus KT. So what you need a plot of P as the question demands versus time. So start with t equal to 0. So if t equal to 0, then e to the power 0 is 1. So 1 minus 1 is 0. So a0 into 0 is 0. So it starts with from the origin. But as time increases, so this value decreases because minus kt is there. So this value decreases and 1 minus this total value increases, so it gradually goes up. And then what happens after time t, because you know that first order reaction never completes, so it takes infinite time in principle to complete. So when t is infinity, that e to the power minus infinity is 0, so 1 minus 0 is 1, so p is a0. That means it will be saturated to some value, that value is a0. Okay, so this is the required plot. Hope you have got the point. Let us go for the next slide. Plot of rate versus time. So again rate versus time, but this time for a zero order reaction. It is very simple. R equal to k e to the power 0, that means R equal to k. So R is actually constant. So with increasing time, R doesn't change. So the plot is going to be a straight line parallel to the x-axis. That means if it is your time and if this y-axis is your rate, then at certain value it will start, and suppose this is the k, this is the k value, and it's constant, so it goes parallel to the x-axis. That is the required plot. Okay. Next question: a catalyzed and uncatalyzed reaction, reactant concentration versus time. So it is simply that if you know that the role of a catalyst actually accelerates the process or reaction. So it is simply that it would be suppose this is the uncatalyzed fast and this is the uncatalyzed. So this kind of so this is uncatalyzed and this is catalyzed. Okay, that's all about this problem. So let us go for the next one. Log T half versus log A0 for a zero order reaction. So it will start with the expression of T half for zeroth order reaction. So you have to remember that T half is A0 by 2k, but log is required, so take logarithm of both sides. So log T half equal to log of 1 by 2k plus log of A0. So now you need actually you are with the required equation, that log T half and log A0. So it's clearly a straight line with an intercept, so and a positive slope. And what is the value of the slope? Here the slope is m is 1, right, and intercept is there. So this is the log T half and this is your log A0, and the intercept is from figure, it is log of 1 by 2k, and slope is 1. Slope is 1, right? So this is how we deal this expression starting from the known expression T half is A0 by 2. The next question: log rate versus log C for the nth order reaction. So this time it demands that you have to start with an nth order general rate law, and that is k equal r equal to kc to the power n. But log is in the question, so you have to take log r is log k plus n log c. So again, it's not that difficult to understand what the plot is going to be. Log r, if you plot on the y-axis log r, and here log c is the initial is the concentration at the time. So it's a straight line, y equal to mx plus c kind of equation with an intercept of log k. So this is log k, and what is the slope in this case? N log c. So n is the slope. So slope m we usually call slope. So slope is actually here the order n. Okay. So let us go for the next question. ln C versus T plot for a first order reaction. So again, you have to just ponder about the equation, and that is simple. First order reaction ln C is ln C0 minus kt. So again, this time is going to be a straight line. This is y ln C and t is your x. So m is minus t. So slope is minus k, and this is your intercept. So is y equal to mx plus c kind of equation, and it is going to be a straight line again, but with a negative slope because k is itself positive. So if you plot t in x axis and ln c on y axis, then it is going to be a straight line, and here the slope is of course minus k, and this is when t equal to 0, this is ln c. So ln c. So this is the required plot, and let us go for the next question, which involves a third order reaction. The question is log t half versus log a for a third order reaction. So t half. So you have to start, of course, you have to start with the general nth order expression of t half, and that we have discussed in details in the earlier session 5. And this is the t half expression. And then if you just put n equals to 3 as given in the question, then 2 to the power 4, 3 minus 1. So 2 to the power 3 minus 1 minus 1, and this is n minus 1. So 3 minus 1 k, and a to the power n minus 1. So a to the power 3. So it simply gives 3 by 2k a square. Okay. Now you have to plot of log. So you have to take the log. So t half gives you log half, log t half, and 3 by 2k. So you are separating log of 3 by 2k. Now a square in the denominator, so e to the power minus 2, and taking log, so minus 2 log. So again this is y equal to mx plus c, but this time the m is negative because minus 2 is there. So the plot would be like this. This is log a x axis, and y axis is log t half, and the plot would be a straight line with a decreasing so slope, and the slope is minus 2. That is equal to the slope. Okay. Fine. So this is an example of an nth order expression. The next video would be the session 7, and that would be coming soon. I would like to thank you for watching today's session. The next session would be again on chemical kinetics part 4, and that time would be we'll be dealing with some MCQ and MSQ, multiple choice question and multiple select question, taken from IIT JAM and NET. So that would be very helpful for you who are really aspiring for the different competitive exams. And please keep on watching, do subscribe, and encourage your friends to subscribe, to watch, and more particularly to comment, so that I can serve you better. I can further improve the quality of the videos, the content, and whatever you want. And you can also place a request that particular topic that you want actually in your coming session. So thank you very much.